Our next presentation will be a remote one, and I already see Dr. Marcus Hennig from Define is ready to go with his talk about electronic securities infrastructure. Enjoy.
Hi, everybody. I hope you can hear me. I don't have any response, but I think so. So let's speak about the next kid on the block, and it's about electronic securities. And I will focus more on the crypto security side because I think it's much more interesting here. So let's start with the eWpG in Germany. It's a new kind of law, the German Electronic Securities Act. And it brings some novelties and also some new roles and some new possibilities actually to issue financial instruments in a completely digital way. So on the one side, it allows to issue digitally. So if you like to say issue bearer bonds or fund shares, you can already do that. So there's a kind of regulatory framework with the eWpG. If you want to go on the stock side, you still have to wait, unfortunately. But it's also, I would say, the more kind of complicated case because you have a lot of more corporate actions. So there's a kind of challenge involved. And the other thing is apart from say the possibility to issue something digitally is there's a kind of new role, and this is the role of the registrar. So you have to you should have like a kind of register for securities. And this is something like what somebody can maintain or can operate. So you can operate a kind of registry. And if you're a custodian or a CSD, you have like two choices. There's a kind of central and also like a crypto register. So you can operate both. I will come later to them. And if you do that and you have securities in that, you can trade them, say, on MTF. So there's a possibility that they're kind of tradable. If you're not a kind of custodian or a CSD, you can only say operate or run a crypto register, and if you have securities inside, you can only like trade them kind of like OTC. So there's a kind of two classes here, which hopefully will be solved say in the future. But for the time being, it's like that you have. So if you have like securities in the crypto register, you can only trade them OTC. So this is kind of small kind of drawback we have. So the electronic security can be like categorized in kind of two types. So one is like the central register security, and the other one is the crypto security. So they're kind of like from a structure pretty much the same. So the only difference is the way they are kind of registered in the kind of like legal sense. So one are say registered in the crypto security registers, and the other one in the central register. So this is really kind of say difference here in the naming, but say on a kind of like functional side, there's a kind of lot of differences. And you also like have the custodian, and the custodian can like say in the old world conduct the custody business for securities. So this is the eWpG in a nutshell. So what are the implications of that? So the implications is actually that you can digitalize securities. This sounds really simple, but there's a kind of two kind of possibilities you have. Or one is like more you still do it like in a kind of closed setting. So there's like the central register securities, and the other one is in a more kind of open setting. So you can use distributed ledger technology for doing that. And with that, you actually open securities to a kind of new kind of design space, and you also changing the notion of a security. It's going more in the way that you think, okay, the financial instrument is more like a kind of an application with an interface, which is kind of open, and you can connect different use cases or different kind of, say, software components to that. So it's a kind of different way when you look into a kind of closed system where this is not so easily possible. And with this kind of say innovation potential, you can maybe in the future completely design completely new kind of securities. So this is one thing, one kind of implication. The other way is like, because when you have like an open system, or you allow an open system, you can develop a kind of a lot of new services for that. So there's a kind of innovation potential, but at the same time, there's definitely kind of competition, because the first thing is like the monopoly of the CSDs questions, and the other one is like you have a kind of new role in the ecosystem, which can be, say, assumed by an issuer or by any kind of say other person. So there's kind of new role. And with that, you increase competition. And because you have more competition, it will probably also lower the cost. And also in combination with the innovation you could have, you can just really kind of tackle, say, the life cycle events of a security and trying maybe to put them on a distributed ledger. So you have like the processes in a kind of like distributed way, and they can be shared. And when you just think like that the bond can run like 10, 20 years, so there's a really kind of potential that you cut down kind of running costs. The other thing I already mentioned before is this problem that you have like two classes. So you have one class which is kind of tradable in MTF, like say in the old world, and the other one is only traded OTC. So there's a kind of certain limitation here, or a certain kind of drawback. But this is something where I think it will be solved in the future. This shouldn't be like that. So now let's focus more on the crypto security sides. So the question is like, okay, what kind of new roles do you have, and how they are important? So what you can see here is like, say, just imagine like a distributed ledger, and you have crypto security as a kind of smart contract, so like a kind of DApp. So the first new role I already mentioned in the introduction is, say, the crypto, say, security registrar you have. So it's a kind of new kind of service that requires a license, and you can think of as a kind of, say, administrative role here about the securities. And on the one side, it ensures like the legal compliance of transactions. It can validate transactions, and it also reflects kind of a legal situation. So it's just somehow keeping, say, who owns what, and at the same time, say, reflects the existing legal situation. Then you have the custodian bank, and this is like what you already have before. So the custodian bank is responsible for the custody of the securities, and it also can provide, say, asset servicing. But there's also the crypto custodian, which was mentioned in a talk before, because at some point you have to say, store your say, private keys in a really secure way, or operationalize them in a very kind of secure way, and so therefore you have the crypto custodian. So with the securities, with the crypto securities, you have you have private keys where you can control certain kind of functions. So the registrar can control certain functions like whitelisting or changing allowance listing, or also can enforce ownership transfers. And in another way, you have also like investors which can make a kind of transfer, and they need private keys for that, and they can be stored with a crypto custodian. And there's something also what you need for the future, and this is a kind of cash on ledger issue, or at least some kind of digital euro. So this is something which is, I think, really important, or a really important component to build crypto securities. And surely you finally have the investor, and the investor should have the kind of possibility to kind of interact peer-to-peer with a crypto security. Like, for instance, when there's a transfer doing, it can do it by himself. And this is something completely new to, say, the classical world. So if you want to build a crypto security register, a kind of ecosystems, so the first kind of question you have to ask is what kind of DLT you're using. Because I mean, if you decide for a certain kind of distributed ledger technology, you have a lot of kind of implications on, say, privacy, scalability, finality, and so on. So it's really important to make the right choice here. And so the next challenge is actually then to build the registry. And so, I mean, you have this kind of frame, you have the eWpG as a framework, which kind of guides you what kind of function you should implement, but it doesn't solve any kind of technical problems. And the other thing, what you have is like, okay, you have to really think about security here, because actually you're kind of super admin for securities which have really, really high volumes. And the other thing is like you have to think when you build like processes that maybe some parts are on chain, other parts are off chain, and in the same time you have to try to make things really peer-to-peer if possible. This is not possible for everything, but for say a lot of kind of functions of a registry, you can do that, but you always have to really look into the design of your processes. And the other challenge you have is like to realize payments. So, but I think when you start like building something, you will probably say select some kind of really simple kind of securities, like short-term notes or something which is say close to zero bond where you don't have any kind of cash flows. But say in the future you will do that because the most kind of cost savings with all these kind of life cycle events. So you have to realize payments somehow. And so there's different kind of options or different kind of option space you can look into. One is like you can look into trigger solutions. You can look into kind of e-money systems, or you wait for say CBDC or kind of digital euro you will probably have in the future. So like look a bit like building the registry. So from the eWpG, you have certain kind of requirements. One is about the state of the register. So the data should be kind of confidential. You should think about integrity, authenticity. You have to reflect the kind of legal situation, which is a really kind of challenge because there's a lot of kind of cases you will probably have, and you have to build all these kind of processes. Participants or like investors and issuers should be able to see their status. You have to think about like how changes are implemented. So they have to happen kind of like completely, properly, timely, and in a kind of non-voidable way. So this is also important when you choose your kind of distributed ledger technology for that, because you have this kind of problems with finality. So like they require doing it in a kind of timely way. So you have to choose the right ledger. And also like scalability will be really important here. And you have, for the registry, you have like kind of two kind of entry types. So you can have like omnibus or segregated accounts, so like collective or like individual entries. This is really important because like from a privacy protection kind of perspective, say when you're using kind of omnibus account, it's much easier to go for GDPR kind of requirements, say for retail clients, because it's really hard if they would have like segregated accounts. You have to be able to change your security into paper. I mean, under certain conditions, so you can go back into the old world. The other one thing is like saying global certificates can be changed to central register securities. So there's a lot of kind of requirements on a kind of migration. You have certain liabilities in a sense like you're financially liable for any kind of data loss or unauthorized changes. So, but when you have a kind of like when you use a kind of distributed ledger systems, I mean, everybody can accept it. So you really have to look into your security. So this is also goes a little bit down the direction of like crypto custodian. I mean, you probably wouldn't have the kind of same super high kind of requirements, but I think it's getting really, really close to that, because you have to really, for instance, protect the private keys of a registrar, because they can change whitelists, they can change allowances, they can enforce transfers, so probably an attacker could mess up with the system. So you have to really protect that. The other one thing, okay, you have to implement transfer of ownership. I think this is something where, say, you design that, you should do it as kind of peer-to-peer as possible here. So there shouldn't be any kind of, say, communication with a registrar in any way, only with the distributed ledger, so that, say, when both parties agree on an ownership transfer, they can do it peer-to-peer, and as a kind of authorization instrument, you could use the say a digital signature on the blockchain transaction, but then you would have to have the public key on the registry side. So it should be a part of the participant onboarding process. And the other thing is, okay, you have certain kind of data for the financial instruments you have, and there should be, say, for instance, there should be links to the terms and conditions, and you have something about, like, the issuance volume and so on, and this should be like part of your should be considered when you're designing the smart contracts. But also, like, if you're a registrar, I think you are kind of close to the one who's selecting the DLT for the securities. And if you look into, say, open kind of or into like more public blockchains, it's getting more kind of challenge here. Because there's a lot of things you have to consider. I mean, you have this kind of regulatory requirements on the one side, and you also like have privacy concerns. And this is a kind of complicated mix here. If you're in a closed system, these kind of challenges are much easier. But if you're going like on say on Ethereum or some like kind of blockchains, it's getting more kind of tricky. So the first thing you probably would face is like scaling on transaction costs. Say in Ethereum you have like this kind of high gas fees, you have a low kind of throughput here. So you have to really look into the blockchain space. What you can use here, you have to look into like second layer sidechain kind of solutions, or like trying to look into solutions trying to tackle all these kind of issues, like for instance like Solana, which probably is not really stable, not really mature. So it's getting tricky. The other one is the need for kind of cryptocurrencies, because I mean you have to pay gas fees, and so you have to look somehow. Okay, you have to maybe to connect to a broker. You have to maybe hedge the risk here. So you have to look into this kind of cryptocurrency space. The other thing is like privacy. So if you have like say big corporates or say institutional clients as a registrar, they probably don't want that everybody can see their positions or their kind of transactions. So it requires that you're trying to design privacy into solutions. So I mean, when you look into like for corporates or like institutional investors, you can use like one-time addresses, but it's something which doesn't solve the problem completely. You can really say depend on HD or HD structures here. You have one-time addresses. You use a new address for each transfer. So, but it doesn't really solve the problem. So you have to really dig deeper into that if you're on a public blockchain. So there's a kind of lot of kind of privacy solutions where you have like confidential transaction layers and these things. So this is something you have to really look into. Say for retail clients, it's getting a little more simpler. You can probably look into omnibus accounts, because I mean you wouldn't just have kind of say a trace with personal information, or probably personal information on a blockchain. So you can look into omnibus accounts. The other thing is what is the challenge is finality here. So this is something, it really depends on what kind of blockchain or DLT solution you're using. You have to somehow define what is finality. And then you have to probably accept also maybe sometimes really long waiting times. So finality is a big problem. The other one is like, okay, if you look into blockchains, it's not like a kind of cloud provider, so there's no SA or anything like that. There's also no enterprise support. So the first kind of thing you can do is okay, go for a node as a service provider, which probably has an SAA, but it's not the whole blockchain itself. It's just the node. And for the blockchain itself, I think it's getting tricky to find any kind of corporate support here. I mean, there's some blockchains out there which offering something like that, but not all. And the other thing is like, okay, power consumption, which is now, I think, after the merge of Ethereum, probably more easy to solve. So you shouldn't go for like proof of work blockchains. You should more look into the POS space here, like proof of stake. So that's it from my side. So if you have any questions, you can ask me.
First off, a round of applause. Marcus, thank you very much for the great presentation. If there are any questions, I'll give out a microphone. We don't have much time for questions, so please be brief. Up there. Yeah.
I'll be very short. First of all, thanks a lot for the very, very practical and very specific presentation. I think this is very clear in the analysis and the recommendations. My question to you, seeing here, the conclusion seems to be stay away from public blockchains, or at least look at additional solutions to a public blockchain that can address some of the challenges. My question to you is, and playing devil's advocate here, if you are to deploy a private DLT to build a registrar on, how is that any different from the solutions that we currently already have, right? Does it really provide any benefits, or is it worth avoiding the challenges of a public blockchain by deploying a private DLT?
Okay, so I mean, first of all, I mean, I'm not trying to promote actually like say private blockchains. I'm trying to promote more public blockchains. But the problem is like there's a lot of kind of challenges, and I mean, challenges doesn't mean that you shouldn't avoid them. I mean, challenges actually just mean just tackle them and go for it. Because what I would say is like on a private you're going on a private network. I mean, you wouldn't change much, I would say. I mean, you would have maybe more kind of small kind of distributed systems. So if you have a private permissions blockchain, but what you would just not allow would be kind of innovation, what I mentioned earlier. If you're going into the public space, I mean, there's a lot of innovation because, like, think about your security as an application with an interface. So this is actually because, like, when you say in German security, we say like Wertpapier. There's the word paper inside, which is completely strange. If you're going on a public blockchain, or if you're going like say Ethereum
Marcus?
or something like that, yes.
Sorry, didn't want to cut you off, but please, a few last sentences, please.
Okay. So in short, the private thing wouldn't solve much because you wouldn't be in a kind of closed systems, so there wouldn't be much innovation. So what I would suggest is go really into the public space, but consider all these kind of challenges here. So the challenges can be solved. It's a little bit more work, but I think it will pay off at some point because, I mean, you're much more open. You have much more kind of like accessibility to other kind of solutions. So you will probably build a much more richer kind of ecosystem than when you're just going private.
All right. Thank you, Marcus Hennig. I hope you're with us in Frankfurt next time around. And yeah, thank you for the presentation.